the following is an alternative method to solving thermochemical equations. First question reads, when hydrogen peroxide is placed on a cut knee, it decomposes to form water and oxygen gas. How much energy, so we're looking for the amount of energy, will be released when 34 grams of hydrogen peroxide decomposes? Okay, so the first thing we're going to do is we're going to write the given, so 34 grams of H2O2 right above that same molecule. So 34 grams. And we are asked to find energy. So energy is our unknown. So X kilojoules. Okay, so since we're looking for energy, I'm writing it above the energy that's given in the equation. So first thing we're going to do is bring down the units. So I brought down grams there, bringing down kilojoules here. For grams, you need to multiply the coefficient times the molar mass. Okay, so we don't know how many grams react. We need to figure that out. So the coefficient is 2. So I'm going to do 2 times the molar mass of hydrogen peroxide. So if you look at your periodic table, the mass of 2 hydrogen is 2, and then you've got 2 oxygen, so 16 times 2. Let's do it this way. So you have 2 times 1 for the mass of hydrogen, and 16 times 2 for the mass of oxygen, so 32 plus 2, and you're going to get 34 as the molar mass. Okay, so again, this is the coefficient times the molar mass. So 2 times 34, and you're going to get 68. And for kilojoules, you're just going to bring down the enthalpy value, so 200. Okay, so we've got our problem set up. We're not dealing with water or oxygen at all. So we're going to write our ratio. So 34 over 68 equals X over 200. All right, so we are solving for X, and that's going to give us the amount of energy that will be released. So let's start by cross multiplying. So we have 34 times 200, and you'll get 6,800. Okay, so I cross multiplied these, and now we have that set equal to 68 times X. And in order to get X by itself, I'm just going to divide both sides by 6. Oops. Excuse me, 68, missing a number there. So your answer will be 100. Okay, and then for our units, we're going to go back up here. Our unknown was X kilojoules, so my units will be kilojoules. Okay, and then for significant figures, that would be 1.00 times 10 to the 2 kilojoules. Okay, next example. Manganese will react with hydrochloric acid to produce hydrogen gas according to the following equation. And then it says what mass of HCl, so that's what we're looking for, is needed to produce 663 kilojoules of energy. All right, so first let's start with our unknown. We're looking for mass of HCl, so X grams. I'm going to write that right above HCl. I'm looking for the mass of HCl. And then you're given 663 kilojoules of energy. So above my enthalpy, my energy, I'm going to write 663 kilojoules. Okay, next step, we bring down the units. So I bring down grams, bring down kilojoules. For grams, you need to figure out what mass is going to react. So we multiply the coefficient, so in this case is 2 times the molar mass of HCl, which is 36, you'll get 72. So again, the coefficient times the molar mass. So I added up the mass. Mass of hydrogen is 1, and chlorine rounds to 35. Okay, for kilojoules, just like we would for moles, we're just going to bring down that value. So you can think of enthalpy as a coefficient. Okay, so if you bring down kilojoules, just bring down the value for enthalpy that's given. So now we have another ratio set up. So x over 72 equals 663 over 221. And then we cross multiply. So 221 times x equals 72 times 663. And we want x by itself, so I'm going to divide both sides by 221. And your answer is 216. So if we want to figure out the units, we're going to go back to the equation. Okay, our unknown was grams of HCl. So it will be grams of HCl, and we already have the correct number of significant